Very good morning to the viewers. Happy Shivaratri. On this great occasion, I want to share my knowledge with you people. Very good morning to the viewers. So, due to the pandemic situation, as so many of us are unable to complete the syllabus, and maximum there is a time to complete that, and the government has given a time for some more working days are there. So, and from in the month of May, we have the exams, SSC public examination. So, in this contest, today I want to cover the 8 marks question as per the new moral paper issued by the CRT, Telangana. So, I'm sharing the screen. As per the new moral paper issued for this academic year, 2021, there will be a paper combined, paper 1 and paper 2, only a single paper. 3 hours 15 minutes is allotted, 15 minutes for the reading of the questions. And coming to the section 1, we have to solve 6 into 2, 12. There will be a group A and group B. In this, you need to select at least 3 questions from each group. That is your choice. Out of 6, 3. Next, again 6 questions in group B, you are needed to solve 3. So totally 6 questions, 6 to 12 marks. And coming to the section 2, you need to answer any 4 of the 8 questions. 13, 14, 15, 16, 17, 18, 19, 20. Out of these questions, out of 8 questions, you need to answer any 4. So 4, 16 marks. Coming to the section 3, there will be a 4 questions in each group. Each carries 8 marks. So you need to answer any 2 from at least 2 from each group. 23, 24, 25, this question numbers. If you see here, there are 4 questions. Here in group A also 4 questions. Out of these 4 questions, you need to solve any 2. So today I am trying to attempt solving these type of questions so that 4 into 8, 32 marks, and we need 28 marks to get the pass marks. So at least you will be getting the pass mark, those who attend today's live session. So wishing you all the best. Without wasting the time, I'm moving to the first chapter. That is chapter 1, real numbers. In real numbers, we have the concept of natural numbers, whole numbers, integers, rational numbers. In this, coming to the 8 marks question, there will be a question from exercise 1.3. Show that root 2 is irrational. Show that root 2 is irrational. So let us assume that root 2 is rational. We need to prove it is an irrational number. So before that, what will assume that it is a rational number. If it is a rational, then there must exist 2 integers a and b such that root 2 is equal to a by b. As we know the rational number concept, p by q form, where q is not equal to 0. Here a and b are the co-primes. Root 2 is equal to a by b. Cross multiplying b into root 2 is equal to a. On squaring both sides and rearranging, we get 2b square is equal to a square. 2b square is equal to a square. Therefore, 2 divides a square. By theorem 1.6, it follows that since 2 is dividing a square, it also divides a. So we can write a is equal to 2c from some integer c. Substituting for a, we get 2b square is equal to 4c square. That is b square is equal to 2c square. This means that 2 divides b square, so 2 divides b. Again, thus by using the theorem 1.6 with p is equal to 2. Therefore, both a and b have 2 as common factor. But this contracts that fact a and b are co-prime. They are not co-prime. This contradiction has arisen because of assumption that root 2 is rational. Thus, our assumption is false, as we assume that it is a rational number, but it is a co-prime. So we can conclude that root 2 is irrational. So this is a possibility of 8 marks question. Then one more example 8. Show that 5 minus root 3 is irrational. As we assumed in the previous sum, let us assume here also that 5 minus root 3 is rational. That is, we can find co-primes a and b where b is not equal to 0 because p by q form where q is not equal to 0. That is a rational condition. Such that 5 minus root 3 is equal to a by b. Therefore, 5 minus a by b is equal to root 3. By simplifying, bringing the minus ab to this side and root 3 to left hand side, we get root 3 is equal to 5 minus a by b. By taking the LCM 5b minus a, that is equation 1. Since a and b are integers, the RHS of the equation becomes 5b minus a, which is a rational number, and root 3 is also a rational. So, but this contracts that root 3 is irrational. This contradiction has arisen because of our assumption that 5 minus root 3 is rational. So we conclude that 5 minus root 3 is an irrational number. Similarly, we have one more problem. Show that 3 root 2 is irrational number. So by going through this video, you can understand. You can take the screenshots. Next, we have one more 8 marks problem, that is example 10. These are the models which I am discussing. In exam, they may change the numbers. So at least if you write the sum process, at least you will get this minimum marks. Let us suppose that root 2 plus root 3 is rational. Let root 2 plus root 3 is equal to a by b, where a, b are integers, that is co-prime, and b is not equal to 0. So keeping this root 2 in left hand side, bring this root 3 to right hand side, a by b minus root 3. Squaring on both sides, we get root 2 whole square is equal to a by b minus root 3 whole square. A minus b whole square formula, as we know, a minus b whole square is equal to a square plus b square minus 2ab. A square by b square plus 3 minus 2a by b root 3. By rearranging and simplifying, we'll get, that is 2 of a by b root 3 is equal to a square by b square plus 3 minus 2. 3 minus 2, it is 1. This is this 2. So a square by b square plus 1. So again simplifying that, we'll get root 3 is equal to a square plus b square by 2ab. Since ab are integers, a square plus b square 2ab is a rational number. Also root 3 is a rational number. Again this contradicts that fact root 3 is irrational. Hence 2 plus root 3 is irrational. So these are the expectation questions from the exercise real numbers first part, and we have second part logarithm. In that we have the possibility of as 8 marks, that is from exercise 1.5 model. If x square plus y square is equal to 25xy, then prove that 2 log x plus y is equal to 3 log 3 plus log x plus log y. Given that x square plus y square is equal to 25xy. Adding 2xy on both sides, we get x square plus y square equal to 2xy. So in left hand side we added 2xy as well as in the right hand side also 2xy. 25xy plus 2xy will become 27xy. So in the left hand side it is in the form of a square plus b square plus 2ab. That is a plus b whole square. That is a plus b whole square is equal to, that is x plus y whole square equal to 27xy. Taking log on both sides, we get log of x plus y whole square is equal to log 27xy. So as we know the formula, log a to the power of m log a, and log ABC will become log a plus log b plus log c. So here in place of a we have 27, in place of b x, in place of c y. Log 27 plus log x plus log y. So again 27 can be written in the form of 3 cube. Again we can apply the log 3 cube as log a to the power of m formula, that is m log a. Therefore, hence we prove that 3 log 3 plus log x plus log y is equal to 2 log x plus y. In exam, there is a possibility of asking find the value of left hand side or right hand side. The process is same. Question may change, but the solution is same. So be careful, and instead of 25xy, they can give you 47xy or something, which is a perfect square. So moving to the next. If log x plus y by 3 is equal to 1 by 2 log x plus log y, then find the value of x by y plus y by x. So given that log x plus y by 3 is equal to 1 by 2 log x plus log y, log x plus y like 3 equal to log x plus log y whole power 1 by 2. So here log x plus log y, it is in the form of log a plus log b, log ab whole power 1 by 2. Eliminating log on both sides, will get x plus y by 3 equal to xy whole power 1 by 2. Squaring on both sides, here x plus y whole square by 3 square. Here x, the right hand side xy whole power 1 by 2, square and root get cancelled, it will become xy. 3 square is 9, a plus b whole square, a square plus b square plus 2ab, that is x square plus y square plus 2xy. So moving this 9 to that side, it will become multiply 9xy. Send this 2xy to right hand side, 9xy minus 2xy, that is 7xy. Now dividing both sides with 7xy or xy, will get x square by xy, y square by xy. Your numerator and denominator get x cancel, x is left, x by y plus, here in the second term, y square by xy, y get cancelled, y by x is equal to 7. That is our question to find the value of x by y plus y by x, which is equal to 7. Next. In exercise 1.5, we have one more problem. If 2.3 whole power x is equal to 0.23y whole power y, which is 1000, then find the value of 1 by x minus 1 by y. Given that 2.3 whole power x is equal to 1000 can be written as 10 cube. So 1 by x, 1 by x, so x get cancelled, or sending this x to that side, it will become 3 by x. That is 2.3 is equal to 10 to the power of 3 by x. Also given that 0.23y is equal to 1000 cube, because these two values are constant equal to 1000. So as we got the second equation, 0.23 10 to the power of 3 by y. Dividing 1 with the equation 2, 2.3 by 0.23. And right hand side, 10 to the power of 3 by x by 10 to the power of 3 by y. taking the formula of a to the power of m by a to the power of n, a to the power of m minus n, that is 10 to the power of 3 by x minus 3 by y. And in the right hand side, we have 2.3 that can be written as 23 by 10, and 0.23 can be written as 23 by 100. 23 by 10 into 100 by 23, zeros get cancelled, and 23 get cancelled, and we are left with 10 to the power of 1. So, as the bases are equal, power should be equated. 3 by x minus 3 by y is equal to 1. So, taking 3 as common and sending to the right hand side, it will become 1 by x minus 1 by y is equal to 1 by 3. So, these are the some important 8 marks questions from chapter number 1. Now, moving to the second chapter. In second chapter sets, we have an exercise for page number 42, that is exercise number 2.2. If a, b, c, d are given, find the value of a minus b, a union b, all these types of sums. That is exercise 2.5, 2.2, page number 42, 2019-20 printed textbook. In that, if you see page number 42, we have the fifth problem and sixth problem. So we'll try to solve the fifth problem. So a is given as x is a natural number. So the natural number starts from 1, 2, 3, 4, so on. And in set B, it is given as x is an even natural number, where the even natural number starts from 2, 4, 6, 8, so on. C is an odd natural number, that is 1, 3, 5, 7, 9, so on. And D is prime number. Prime number, that is even prime number, is 2, 3, 5, 7, 11, 13, 17, 19, so on. So, for example, he may ask you A union B, A intersection B, A intersection C, A intersection D, A minus B, B minus D, like this. So we'll solve 1 models, that is A union B. So what is A? A is 1, 2, 3, 4, 5, so on. Union B, B value is 2, 4, 6, 8, so on. So as when we write the union, it is start from the least value to the maximum. That is 1, 2, 3, 4, 5, so on, which is equal to A. Therefore, you can conclude that A union B is equal to A. Next, and we do the A intersection B. A is 1, 2, 3, 4, 5, so on. Intersection 2, 4, 6, 8, so on. So the common number will be the even numbers 2, 4, 6, 8. Here we can find 2, 4, 2, 4. So like that it will continue. 2, 4, 6, 8, 10, so on, which is equal to B. So you can conclude that A intersection B is equal to A intersection B is equal to B. So this is the way we'll solve the A intersection B, A union B. And we're coming to the A minus B. A minus B, A minus B. A is 1, 2, 3, 4, 5, so on, minus 2, 4, 6, 8, 10, so on. So when we cancel the common numbers which are present in A and B, 2, 2, 4, 4, here 6 will be there, 6, 8, 10, all will be cancelled. So only we are left out with the numbers which are present in A, because X belongs to A minus B. The definition of A minus B say X belongs to A and it does not belongs to B. This is the definition of A minus B. So whatever the elements which are present in A, that we have to write 1, 3, 5, 7, so on. When we see in the list, it is again C. So A minus B is equal to C. Like this, whatever the first of all, the concept you should understand how to do A union B, A intersection B, A minus B. A union B is the combined writing the values which are present in set A and set B from the in an ascending order, that is smallest number to the biggest. In A intersection B part, whatever the common part, that is intersection we are seeing, the common part we have to write. Coming to the A minus B, as the A minus B definition says, X belongs to A and X does not belongs to B. So 1, 3, 5, 7, only the elements which are present in A. So, we'll solve one more concept in this, that is D minus C. So D 2, 3, 5, 7, 11, 13, so on, minus C 1, 3, 5, 7, 11, 1, 3, 5, 7, 9, 11, 13, so on. So D minus C, the question is D minus C, and we cancel the values which are common. 3 get cancelled, 5 get cancelled, 7 get cancelled, 11, 13, so on. Here 2 is left, and after that we have some more digits also. So that is 2. Here 2, 3, 5, 7, 11, 13, 17, 19, so on. So these are the numbers which are present in the set A. So D minus C, that is X belongs to D, X belongs to B, and X does not belongs to C. Even here some numbers are left in C, we are not bothered. So generally I say an example that when you are thinking about A minus B, when we are solving A minus B, we need to think. An example, suppose if you take a two friends' house, you and your friend, they may have the fridge, you may have the fridge. They may have the TV, you may have the TV. They may have the car, you may have the bike. So what is common? Fridge and TV is common in both the house. But coming to the car, bike, vehicles, they have the car. You don't have the car. So what is extra? That is car. So X belongs to A but not B. If it is the reverse case, you will be taking your friend's bike as an answer. So like this, you need to think apply the situation in the practical way. So these type of question and some more and Venn diagram you may get. Moving to solve the Venn diagram, let A 1, 2, 3, 4, 5 and B say 4, 5, 6, 7. We try to solve the Venn diagram. So 1, 2, 3, 4, 5. A is value is 1, 2, 3, 4, 5 and B is 4, 5, 6, 7. So common is 4, 5. So write in the intersection part 4, 5 and the elements 1, 2, 3. In coming to the B set 6, 7. So A union B from the Venn diagram it will become 1, 2, 3, 4, 5, 6, 7. So this can be asked in the pictorial representation as we know the academic standards problem solving, reasoning and proof, communications, connection and visualization and representation. Visualization and representation. Dear students, all chapters will be covered, don't worry. So, thank you, Tanish Singh. Yes, sorry. A union B, 1, 2, 3, 4, 5, 6, 7. We can see in the visualization representation 1, 2, 3, 4, 5, 6, 7. And A intersection B, the common part is 4, 5. And A minus B, only this part we will be writing. So the elements which are present here. So we can see 1, 2, 3. And when we ask B minus A, we have only this part, that is 6 comma 7. So this is the visualization and representation question. Next, moving to the third chapter. In third chapter, we have question from the finding the zeros. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. find the zeros of and verify the relationship between the zeros and the coefficients. So take x square plus 5x plus 6 as an p of x is equal to x square plus 5x plus 6. When we find the factors, that is splitting the middle term, so as per the condition 1, coefficient of x square 1 into 6 is equal to 6. Second, 5 can be written as 2 plus 3, and the third condition says 2 into 3 equal to 6. So the splitting the middle term we can do the perfectly. X square plus 2x plus 3x plus 6. Taking x as common, x plus 2 plus 3 common, x plus 2. So x plus 2 into x plus 3. So therefore x square plus 5x plus 6, its factors are x plus 2 and x plus 3. That means x minus 2, x minus 2, x is equal to minus 2 and minus 3 are the zeros of this given polynomial p of x, quadratic polynomial x square plus 5x plus 6. So, considering this as one is alpha, one is beta, alpha is minus 2 and beta is minus 3, alpha plus beta is equal to minus 2 plus minus 3, that will become minus 5. Alpha into beta minus 2 into minus 3, that is plus 6. This is by finding the zeros, but by using the verification by sum of the zeros, that is alpha plus beta is equal to minus b by a, minus 5 by 1, which is minus 5. Second, alpha into beta c by a, c is 6 by 1, which is equal to 6. So when we see, we got same. By finding the alpha and beta and solving, substituting in the alpha plus beta and alpha into beta, we got minus 5 and plus 6. By coefficients also we got the same. So this can be expected for the 8 marks question. So this is the positive case. I'll solve one more negative case. X square minus x plus 6. So the first condition 1 into 6 is 6. Second, minus 1. Minus 1, x square minus x minus 6. So minus 6. Minus 3 plus 2 will become minus 2. So third, minus 3 into 2 is minus 6. Again, the first and third condition satisfied. So this p of x can be as x square minus 3x plus 2x minus 6. X common x minus 3 plus 2 x minus 3. That is x plus 2 into x minus 3. That means alpha is minus 2 and beta is 3. Because as we know the x plus 2 equal to 0, x is equal to minus 2. So by applying that, we'll get alpha is minus 2 and beta is 3. So alpha plus beta, substituting the value minus 2 plus 3 will become 1. And second, alpha into beta minus 2 into 3, that is minus 6. When we apply the coefficient conditions, alpha plus beta is equal to minus b by a minus b, that is minus of minus 1 by a 1, which is equal to minus into minus plus 1 by 1 is 1. Second, alpha into beta c by a, that is minus 6 by 1, which is equal to minus 6. So when we see we got the same value, so it is verified. Good, Tanishq. So this is the possibility of 8 marks question. As this time we have not concerned with the root cubic division is exempted for this time, and there will be a question of graph from this chapter. Next, solving the linear equation, pair of linear equations x plus moving to the optional exercise. There is a sum 2 to the power of x plus 3 to the power of y is equal to 17. And one more is 2 to the power of x plus 2 equal minus 3 to the power of y plus 1 equal to 5. So 2 to the power of x plus 2, and we apply the form a to the power of m plus n is equal to a to the power of m into a to the power of n. So this can be written as 2 to the power of x into 2 square minus 3 to the power of y into 3 to the power of 1, which is equal to 5. So 2 square is 4, 4 into 2 to the power of x and minus 3 into 3 to the power of y equal to 5. So let we assume that 2 to the power of x is equal to a and 3 to the power of y is equal to b. So the first equation will become a plus b equal to 17. So as we can see here, the equation is 2 to the power of x plus 3 to the power of y equal to 17. So a plus b equal to 17. This is equation 1. And coming to the second equation, 4a minus 3b equal to 5. This is equation 2. Solving equation 1 and 2. Solving the equation 1 and 2, that is a plus b equal to 17, 4a minus 3b is equal to 5. This is equation 1, equation 2. Either you need to equate the coefficient of a or coefficient of b. It is your wish. So here I am doing the coefficient of b as equal coefficient. So I'll multiply the first equation with 3 and second equation with 1. So 3a plus 3b equal to 17, 3 is 51. 4a minus 3b equal to 5. Now adding plus 3b minus 3b get cancelled. 4a plus 3a, that is 7a equal to 56. A value is 56 by 7. 7178. So a value we got as 8. That if you substitute in the first equation, we'll get a plus b equal to 17. 8 plus b equal to 17. That is implies b is 17 minus 8. B is 9. But in the question, there is no question of a and b as we assume. So what is the original value? A we assumed as 2 to the power of x is as a. That means 8. So 2 to the power of x is equal to 2 cube. So x is equal to 3. And 3 to the power of y we assumed as b, which value is 9. 3 to the power of y is equal to 3 square, y is equal to 2. So at last we conclude that x is 3, y is 2. So from the starting, I'll try to explain once again the whole sum. The given equation is 2 to the power of x plus 3 to the power of y equal to 17, and the second equation is 2 to the power of x plus 2 minus 3 to the power of y plus 1 equal to 5. So second equation can be simplified by 2 to the power of x into 2 square minus 3 to the power of y into 3 equal to 5. That is 2 square can be written as 4, 3 to the power of y, 3 to the power of y, 3 into 3 to the power of y equal to 5. So let us assume that 2 to the power of x is a, 3 to the power of y is equal to b. So a plus b is equal to 17, 4a minus 3b equal to 5. Solving the equation 1 and 2, for that we'll multiply with 3 and multiply with 1. The first equation is multiplied with 3. So 3 into a, 3a, 3 into b, 3b, 17, 3 is 51, 1 into 4a minus 3b equal to 5. By solving 7a, that is adding the 3a and 4a value, we get 7a. 51 plus 5, that is 56. After simplifying, we will get a is 8. Substitute this 8 in the equation 1. A plus b equal to 17. 8 plus b equal to 17. That is b is equal to 17 minus 8. B is 9. So 2 to the power of x we assumed as a, but we got a value as 8. So substitute that. 2 power x is equal to 2 cube, because 8 is can be written as 2 cube. X is equal to 3, and 3 to the power of y is equal to b, that is 9. 9 can be written as 3 square. When bases are equal, power should be equated, y is equal to 2. Therefore, x is equal to 3, y equal to 2. So in this example, two things are covered. One is how to solve the pair of linear equation, and it can be asked in the connection question also, because in the first chapter real numbers, exponents, applications are there. So it can be asked in the connection. That's why I choose this sum. Even some more questions are there where you can apply the concept, like both sum, complementary sum, and the taxi sum is there. So we'll try to solve the sum of two-digit number, and the number obtained by reversing the digit is 66. If the digit of the number differ by 2, find the number. How many such numbers are there? This is a problem from chapter 4.2, exercise 4.2, second exercise, second problem. The sum of a two-digit number and the number obtained by reversing the digit is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? And the larger of two supplementary angles exceeds smaller by 18, find the angles. The fourth problem is there. The taxi charges in Hyderabad are fixed along with the charges for the distance covered up to first 3 kilometers. You will be charged a certain minimum amount. from there onwards, you have to pay additionally for every kilometers traveled. For the first 10 kilometers, the charge paid is rupees 166. The 15 kilometers, the charge paid is 256. So, what are the fixed charge and charge per kilometer? How much does a person have to pay for traveling distance of 25 kilometers? When we observe the question, for 10 kilometers it is 166, and for 15 kilometers it is 256. So the most of the students, they will do a mistake because the question is 25 kilometers. So 10 plus 15 is 25. So they will start adding this, but that is the wrong way. So this is the pulse of a student where the paper setter will think that the question may go wrong by the student. So you need to practice. When a question is said is important, it is not point of the examination. It is in the point of the student where the student can possibility of doing a wrong. So be careful while solving this. So practice this type of question. So as it is not possible to solve all the problems, next, a complementary angle. Sorry. Two angles are complementary. The larger angle is 3 degrees less than the twice the measure of the smaller angle. Let the two angles be x and y, where y is greater than x. Assuming that y is greater than x. So the first condition says, case 1, two angles are complementary. As we know, complementary means x plus y is equal to 90. So we got the equation. The larger angle is 3 degrees less than twice the measure of the smaller angle. So as we assume that y is greater than x. So case 2, y is equal to 3 degrees less than twice the measure, that is 2x minus 3. 3 degrees less than the twice the first angle. So find the measure of each angle. As we got y is equal to 2x minus 3, we can substitute in the first equation. Substituting y in equation 1, that is x plus y equal to 90, x plus 2x minus 3 equal to 90, 3x equal to 90 plus 3, x is equal to 93 by 3, 3 ones. So x is 31, y is 2 times of 31 minus 3, that is 2 into 31, that is 62, 62 minus 3, 59. As you know, 59 plus 31 is 90. So this type of question, because again there may be a change, instead of supplementary, complementary. They may ask you for supplementary, complementary, instead of complementary, supplementary. So the same question, if you asked in the complementary, are both for 8 marks, they can combine. That is x plus y is equal to 180, y is equal to 2x minus 3. Substitute now, x plus 2x minus 3 equal to 180. That is 3x is equal to 180 plus 3. X is 183 by 3. 3 6 are 18, 3 ones. So y is equal to 2 times of 61 minus 3. 2 times of 61 minus 3. That is 122 minus 3. 119. 119 plus 1, 120 plus 60, 180. So this both combinedly they may ask. What happens in the case of supplementary? They may add the question. So this is the solution for it. Like this, in this way, we can solve the sums which are in exercise 4.2, 8 marks questions. And a dictionary has a total of 1382 pages. It is broken into two parts. The second part of book has 64 pages more than the first part, as we are seeing here. X plus y is equal to 90. Here we'll write x plus y is equal to 1382. And the y will become 64 pages more than the first, x plus 64. Substitute, you will get x plus y is equal to 1382 pages. And the second case is y is 64 pages more than the first part. First part is x, second part is 64 pages more. So y value is x is x plus 64. Substitute in this, x plus 64 plus y equal to 1380. X plus, sorry, x plus 64 equal to 1382. Y has been replaced with x plus 64. 2x 1382 minus 64. 12 minus 4, 8. 7 minus 6, 1. That is 300, 1018. So x is equal to 131852. 2 6 are 12, 2 5 is 10, 2. So x value is 659. Y will become x plus 64. That is 659 plus 64. 3, y plus 6, 11, 730. So cross verification 713659. If we add 2, 1 carry, and it is 1382. So in this way, we can solve the sums of pair of linear equations, and conditions based sums will be there, and even the linear pair of linear equations will get a one question based on the graphical representation. So practice that graph sums. Next, moving to the quadratic equation. In exercise 5.2, there are few problems that can be asked for the 8 marks. That is, the altitude of a right triangle is 7 centimeters less than its base. If the hypotenuse is 13 centimeters, find the other two sides. The right angle triangle, let ABC, right angle at B. The altitude of a right angle triangle is 7 centimeters less than its base. That means base is x. So this will become x minus 7. And hypotenuse is given as 13. Solution. In triangle ABC, angle B is 90 degrees. Let the base AB be x. So that is centimeters, and AC is equal to 13 centimeters, and BC is x minus 7, since it is given. So applying the Pythagoras theorem, AC square is equal to AB square plus BC square. 13 square is equal to x square plus x minus 7 whole square. X square plus x square minus a minus b whole square, that is 2 into 7, 14x plus 7 square is 49. 13 square is 169. X square plus x square, that is 2x square minus 14x plus 49 minus 169 equal to 0. 2x square minus 14x minus 9 minus 9 0, 16 minus 14. 16 minus 4, that is 120. As it is possible to divide with 2, so take out 2 common or divide with 2. 7x minus 60. So by finding the factors, we'll get x square minus 12x plus 5x minus 60 equal to 0. X minus 12 plus 5 common x minus 12. X plus 5 and x minus 12. So x is equal to minus 5 and x is equal to 12. So x value can be taken, that is base as 12, because we can't take base as negative values. We never say what is your age. I am so many years. I'm minus 5 years, no one will say. We'll say at least 12 years. Positive values will discuss. And what is your weight? I'm minus 5 kgs, that is wrong way of expression. Positive values, that is 12. So x is equal to minus 5 is not possible. X is equal to 12 is possible. So when x is 12, that means base is 12 centimeters, and height BC will become 12 minus 7, that is 5. And cross check verification, you can see 12 square is 144, 5 square is 13, 25. Total is 169, which is equal to 13 square. And as we know, 12, 5, 13 are the Pythagorean triplets. So our sum is correct. So these are the small tricks you can apply for cross verification. No need to wait for the till you get the results, or till you come and talk with your teacher whether you are done correct or wrong. So Yashwant, the question is, what if any quadratic equation is fractional form? You have this on 3 marks. Muskan, yes, what is your doubt? Myra Muskan, what is your doubt? ESDK. Sir, if you explain the math paper 2, yes, I will try to explain maths paper 2 also. Please follow these links and subscribe so that you will get up-to-date information. Next 2 months, I want to help you people by conducting these programs. Tanish saying, how to prove root 2 as irrational number, or solve that one. Muskan, how it came 7. 7 we have in the question, if you see here, BC is taken as x minus 7. X minus 7. The condition is that the altitude of a right triangle is 7 centimeters less than its base. So whatever the base is there, 7 centimeters less. Base we consider as x. So we have removed 7, x minus 7. So as in the last we got x value as 12 centimeters. As I said, will not never take minus. So positive 12 minus 7, that is 5 centimeters. This is 5 centimeters. Muskan, Mera Muskan, is it, have you clarified your doubt? Okay, very good. Yes, sir. Thank you for responding. Thank you to our teachers and the management, whoever forwarded my message to you. And some people are benefiting today by this section. I hope so. Next. In exercise 5.3, question number 4, exercise 5.3, question number 4. The sum of the reciprocals of Raymond's age in years, that is 3 years ago and 5 years from now, is 1 by 3. The sum of the reciprocals of Raymond's age in years, it is given 3 years ago and 5 years from now. So find his present age. Let Rahman's present age be x years. So this is present 3 years ago, means that comes as past, and 5 years from now, that comes as future. So if present age is x, then past 3 years ago, suppose for example, you people who are watching, a 10th class student, he is now 15 years. 3 years back, that means when he is studying in 7th or 8th class, he will be 12 years. How we got 12? 15 minus 3. 15 minus 3 is 12. So after 5 years, now present it is 5, 15. 15 plus 5 after 5 years, that means in 2026, he or she will be 20 years doing the graduation. 3 years back, studying 7th or 8th class. Here, degree first year or second year. So in the same way, Rahman's present age is x years. So what about his age before 3 years? So in that case, what we'll do? We'll write x minus 3. After 5 years, it is mentioned 5 years from now, 3 years past. So x plus 5. Now the question is sum of these two, the past and the future, its reciprocal sum is equal to 1 by 3. So moving this aside, 1 by x minus 3 plus 1 by x plus 5 is given as 1 by 3. Here where you can write a condition x is not equal to 3 as well as x is not equal to -5. So taking the LCM as x minus 3 into x plus 5. So cross multiply x plus 5, x minus 3. Because in the first term, denominator x minus 3 is there, x plus 5 is missing. So multiply the numerator and denominator with x plus 5. That's why we got x plus 5. In the second term, 1 by x plus 5, x plus 5 is there, x minus 3 is not there. So multiply and divide with x minus 3 so that the denominator will become equal. So that's we call it as LCM part calculations. So which is equal to 1 by 3. So x plus x, 2x, 5 minus 3, that is 2, into 3. This 3 we are bringing to this. So that is cross multiply. 1 into x minus 3, x plus 5. Open the brackets. 6x plus 6. X into x, x square. X into 5, 5x. Minus 3 into x, minus 3x. Minus 15. 6x plus 6, x square. Plus 2x minus 15. Bring this left hand side part to right hand side. And we try to solve. We get x square plus 2x minus 6x minus 15 minus 6 equal to 0. That means x square minus 4x minus 21 equal to 0. So this is the quadratic equation we got, x square minus 4x minus 21. If possible, you can do factorization method. If not, you can solve by Sridharacharya formula, that is minus b plus or minus root of b square minus 4ac by 2a. So here it is possible, it is not a complicated sum. So 7 3 is 21, 7x plus 3x minus 21 equal to 0. X common, x minus 7, 3 common, x minus 7. X plus 3 into x minus 7. X plus 3 plus 3, when it goes to that side, it will become minus 3. X is equal to minus 7 will become plus 7. As we assume that x as the age, present age of Rahman's. So present age means it will be in the positive value, not in the negative value. So x will be 7. That means Rahman's present age is equal to, he is 7 years old boy studying second or third class. So 3 years back means 4. 5 years 12. So how far it is correct, we can check. 1 by 3 years back is 4 years, and after 5 years 7 plus 5 it is 12. So the LCM is 12. 4 3 is 12, 3 and 12, that is 1. 4 by 12, which is equal to 1 by 3. 4 ones, 4 threes, 1 by 3. That is the given condition. You can see. The given condition is reciprocal of the Ramon's age 3 years back and 5 years after now is 1 by 3. Even we got after simplifying as 1 by 3. That means our sum is perfect. These are small things you can verify yourself, and no need to, as I said earlier, no need to wait for till you get the result. So I hope So moving to the next topic, that is progressions. In progressions, this time the GP sums are reduced. So mostly we'll get from the AP, arithmetic progressions. So how many digits, two-digit numbers are divisible by 3? Or check whether minus 150 as a term of AP 11852. Or how many three-digit numbers are divisible by 7? How many multiples of 4 lies between 10 and 250? These are the possibility questions for 8 marks. And Subbarao sum is there. And sum of the fourth term and eighth term. Which term of AP? So simply they will not give for 8 marks a small questions. If they make combine, so that type of questions you need to practice. So, and in exercise 6.3 there are verbal problems. In page number 151 you'll find 11, 12, 13, 14 log sums, bucket sum is there, spiral, and school students. These types of sums you need to practice. So here all it is not possible to solve. Try to understand. So we try to solve page number 144, exercise 6.2, 11th sum. How many three-digit numbers are divisible by 7? How many three-digit numbers are divisible by 7? So that immediately should get 7 table. 3 digits number starts from 100. 99 is the largest two-digit number. So smallest three-digit number is 100 and the largest is 999. But check whether if you are perfect with the 7 table you can understand. 14 sevens are 98. 98 plus 7, that is 105. 105 is the smallest three-digit number which is divisible by 7. So coming to the largest, check whether 999 is divisible with 7. 7 1s 7, 29, 7 4s 28, 19, 7 2s 14 again, and remainder 5. That means from 999 minus 5, you will get a number for 994. So that is the largest three-digit number which is divisible by 7. So we got two digits, 105, 112, 119, so on, 994. These are in AP as well as it is divisible by 7. So A is equal to 105, D is equal to A2 minus A1, that is 112 minus 105, it is 7, and L is 994. So the question is how many are there? So N we need to find. L is equal to 994. L is nothing but the last term or nth term. As we know, the nth term formula is A plus n minus 1 of D equal to 999. Sorry, it is 994. A, it is 105 plus n minus 1 into 7. 994 n minus 1 into 7 equal to 994 minus 105. So in the rough column you do subtracting of 994, 105 is 9, 8 minus 0, 8, 9 minus 1, 8, 889. So n minus 1 is equal to 889 on 7. Now divide this 889 with 7. 717, 1, 18, 7 2s 14, 4 9 carry down, 7 7 14. So 127. N minus 1 is 127. But we need the value of n. N is equal to 127 plus 1, that is 128. There are 128 numbers of 3-digit numbers which are multiple or divisible by 7. 105, 112, 119, and 1994. These are the 3-digit numbers. A is 105, D is A2 minus A1, that is 112 minus 105, that is 7. L is 994, and N is the question mark we need to find. So as we know, L is A plus N minus 1 into D equal to 994. 105 plus N minus 1 of 7 is 994. N minus 1 into 7. 994 minus 105, 889. Divide with 7, we get 127. That is n equal to 127 plus 1, 128. So there are 128 numbers which are divisible by 7. I hope you are following. If yes, next. The same 16th problem is there. The sum of 4th term and 8th term of AP is 24. That is A4 plus A8 is 24. This is given. Given data is 4th term plus 8th term equal to 24. And one more condition is 6th term plus 10th term is 44. Then find the first 3 terms, that is A, A2, A3. A1, A2, A3. So A4 plus A8 is equal to 24. A4, as we know the formula, AN is equal to A plus N minus 1 into D. A4 means A plus 4 minus 1, that is 3D, plus A8, A plus 7D equal to 24. A plus A, 2A plus 10D equal to 24. Take out 2 common, A plus 5D equal to 2. Just keep it as equation 1. Here A6, A plus 5D, A plus 9D equal to 44. A plus A, 2A, 5D plus 9D, that is 14D equal to 44. Again divide with 2, A plus 7D equal to 40. So divide with 2, 22. A plus 70 equal to 22. This is equation 2. From equation 1, we'll get A is equal to 12 minus 5D. This substitute in the second equation. 12 minus 5D plus 7D equal to 22. 12 minus 7D minus 5D, that is 2D, equal to 22. 2D equal to 22 minus 12. 2D equal to 10. D equal to 5. So as we got D value, substitute in this. A equal to 12 minus 5D. 12 minus 5 into 5. 12 minus 25 minus 13. So A is minus 13, D is 5. The question is to find the three terms, first three terms. A is minus 13, A2 minus 13 plus 5, that is minus 8, A3 minus 13 plus 2 into 2D, minus 13 plus 10, that is minus 3. So minus 13, minus 8, minus 3, so on are in A. So this is the sums from the exercise 6.2. Now the most coordinate geometry, there are few problems which are related to 8 marks, that is trisection, 4 parts are showing that the points forms vertices of a square or rectangle, triangle, quadrilateral, that type based questions. Whatever maybe you apply the distance formula, you will get. As we know the distance formula, A x1 comma y1, B x2 comma y2, AB equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. So distance, based on the distance formula, we have so many questions. That is, show that the vertices forms a rectangle or a quadrilateral or trapezium, parallelogram, square. So apply the properties, whatever may be the question. You try to find the distance between the four sides and its diagonals. AB, BC, CD. If all these distances are equal and even the diagonals, check. If the diagonals are not equal, then we can say it is a rhombus. If the diagonals is also equal, then we can say it is a square. It is all. If opposite sides are equal, you can say it is a parallelogram or a rectangle. Triangle, there are A, B, C. You can same find the distance between AB, BC and CA. If two sides are equal, we'll say it is isosceles triangle. And squares of these two is equal to the hypotenuse, then we can say isosceles right angle triangle. If all these three sides are different, we can say it is a scaling triangle. If all the three sides are equal, it is an equilateral triangle. So whatever we are, the questions are different, but we are solving to by applying the distance formula. Let's see. Question. Find the point on x-axis, which is equidistant from 2 comma minus 5. Let the point P, which is lying on x-axis, x comma 0, which is equidistant from 2 comma minus 5 minus 2 comma 9. A, P. The given that PA is equal to PB. There is a point which is on x-axis. There is another 2 points A, B. That means PA distance is equal to PB distance. PA is equal to PB. Squaring on both sides or applying the distance formula x2 minus x1. The benefit of this formula is that is square is there, so you can apply anywhere. 0 plus 5. X plus 2 whole square. 0 minus 9 whole square. Both sides squares get cancelled. Square roots. So left hand side left part is x minus 2 whole square and 0 plus 5 whole square. X minus 2 whole square is in the form of a minus b whole square. A square minus 4x plus 4 and 5 square is 25. Here in the right hand side part, x plus 2 whole square, x square plus 4x plus 4 plus 9 square is 81. Both sides x square get cancelled. I left with minus 4x plus 29, 4x plus 85. Interchanging the values, that is transposing like terms. Minus 4x, 85 minus 29. Minus 8x, here it is 56. So x is 56 by minus 8, 817. X is equal to minus 7. So the point will become x comma 0, that is minus 7 comma 0. So there is a point minus 7 comma 0 which is equidistant to the points, given points A and B. So this type of question, earlier they used to ask for 4 marks, then we can expect for this for 8 marks. Thank you. Thank you, Nidhi. Thank you to the students, those are watching lively. If you have any doubt, you can ask me. Yes, this is SSC board sums, but the concepts are same whether it is a CBSE or SSC. So moving to the next sum from this chapter. Thanks for spending your valuable time for your bright future. Now moving to the find the trisectional points of the line joining 2 comma 6 and minus 4 comma 8. So trisection means the given line segment 2 comma 6, A point B point is there 2 comma 6 minus 4 comma 8. It is divided into 3 parts. Say P, Q. So this is equally divided into 3 pieces. So what are the points we need to find? So what is the possibility? Means these are all in the 1:1. 1, 1, 1. So when we come, see here, 1 plus 1 is 2. So 1:2, or if we take like this, it is 2:1. So there are two cases possibility. First case will give the, when we take 1:2, P value, 2:1 will get Q value. So two cases we need to do. So as all of us know the formula, section formula, M1x2 plus M2x1 PQ will find P is equal to, for that case 1, in case 1 we'll write M:n value as 1:2. So P is equal to M1x2 plus M2x1. M1 is to M2 is 1:2. M1 plus M2, M1y2 plus M2y1 by M plus M, M plus M, M1 plus M2. Either you can take M1 is to M2 or M is to N. There is no problem. M1x2. This is x1, y1. This is x2, y2. M1 is 1. X2 is minus 4. Plus M2 is 2. X1 is 2. By 1 plus 2. Again, M2 is, M1 is 1. Y2, that is 8. M2 is 2 plus Y1 is 6 by 1 plus 2. Minus 4 plus 4 upon 3. 8 plus 12 upon 3, which is equal to 0 upon 3, 20 upon 3. It comes as 0, 20 upon 3. So this is the P point. Similarly, we'll find for the Q. That is case 2. Keeping this aside. Case 2. In case 2, we'll take M1 is to M2 as 2:1. Here we have taken 1:2. Now we are taking 2:1. See, 1 plus 2 is 3. 2 plus 1 is 3. So Q is equal to M1x2. M1 is 2. 2 into, the values are 2 comma 6 minus 4 comma 8. 2 into x2 is minus 4. 1 into 2 by 2 plus 1. 2 into 8 plus 1 into 6 by 2 plus 1. That is minus 8 plus 2 by 3. 16 plus 6 by 3. And we simplify, we get minus 6 by 3, 22 by 3. That is minus 2 comma 22 by 3. So these are the two values we got. So P and Q. The same way, in exercise 7.2 we have one question. Find the coordinates of the points which divide the line segments into 4 equal parts. The same exercise we have third problem, second problem as trisection. Trisection means 1:2, 2:1. But in the case of 4 equal parts, so there will be one more case extra. A, B, say P, Q, R. It is divided into equal parts of 1:1:1. That is 3:1, or it can be 1:3, or it can be 2:2. Because 1 plus 1 is 2, here 1 plus 1 is 2. 2:2 is nothing but 1:1. That means you can apply the midpoint formula. Q is the midpoint of AB, and P is the point 1:3, and R is the point 3:1. So 3 cases it is possible. So what are the cases? I'll write. Formula is same. Section formula. Case 1, M1:M2 will take is as 1:2. Case 2 will take M1:M2 as 2:2, that is 1:1. Midpoint formula. It's better. Directly you can apply. Case 3, M1:M2, sorry, so 1:3, 3:1. 1:3, 3:1. So 3 cases are possible. In the trisection, we have only 2 cases, that is 1:2, 2:1. But here, one more case is joined in the middle. So, in exam, suppose if you have forgot, say, you forgot to write the formula, learn the formula of section. M1x2 plus M2x1 by M1 plus M2. M1y2 plus M2y1 by M1 plus M2. This is section formula. But you are getting somewhat confusion. In classroom means you may ask to your friends, but in the board examination they are not permitted to peep in the others and talk with others. So at that case, how to solve? There was a confusion in the formula. You know the problem all there, but in examination hall there is a problem. So how can you find? So you can find, as we are remember the midpoint formula, apply the midpoint of AB, you will get Q. Now taking the midpoint of AQ, that is P, and QB, R. Apply the midpoint formula to AQ, you will get P. Apply the midpoint formula to QB, you will get R. Before that, you need to apply the midpoint of, taking the points AB, you will get the first Q. So Q, find the Q, then find P, then find R. So only with the formula of midpoint. In that also you will get the same solution. So thank you for the viewers who have spent their time, valuable time for watching this and subscribing. In this part, have covered the 1 to 7 chapters, the most important questions, and I'm keeping in the mind with my experience that possibilities. At least, at least whatever is solved, in that if you are able to solve two questions, then 2 into 8, 16 marks. So if you remember these concepts, at least you can get 50% of this in other sections. So 24 marks. And objective part, if you are able to answer out of 7 chapters are covered, the main things. So if you are able to answer 4 1 marks question, easily you can get 28 marks by this session. In past 2 hours, whatever minimum pass marks you will get. So coming to the paper 2, we'll have one more section. Please subscribe and watch this video till the end and subscribe. And those who are live streamed from past 1.5 hour, more than 1.5 hour, I'm thankful to them, to their teachers and the management. By this, I'll try to end this session. We'll meet in the next session with the paper 2. Here today we have covered the paper 1. Good morning. So thank you to all the students from the different regions. Those who are logged in, thank you, thank you once again to all. So by this live section is going to end. Thank you to one and all.